Hey there, in this video we're going to look at a few more examples of problems where we're using our different exponent properties to multiply expressions, and then in a little bit we'll also look at dividing. So let's start with the example on the top left. First, let's deal with these parentheses. When we have an exponent that is outside of the parentheses, that exponent should be distributed to both of the bases that are inside the parentheses. So negative 2 to the power of 3, that means negative 2 times itself 3 times, which is negative 8. And x to the power of 3 is just x to the power of 3. In this expression, the only thing that's different is now this 2 inside the parentheses is positive. Well, positive 2 to the power of 3 is 2 times itself 3 times, which is positive 8. Now that we've distributed our exponents, we want to multiply these two expressions together. And when we do that, we're going to multiply the coefficients in front of our variables. Negative 8 times negative 8 is negative 64. And when we multiply x to the third times x to the third, we add together those exponents because it's a common base, so we get negative 64 x to the power of 6. Now over here on the left, we'll do another example, and notice now that we're multiplying 3 terms together, but it's just the same as multiplying 2 terms. We're just going to go one step at a time and use our properties as we go. So first, let's deal with the parentheses. This exponent needs to get distributed to both of those terms on the inside. Both of those bases. I guess technically we would say this is just one term, 3x. So we're distributing the exponent 2 to the 3. 3 to the power of 2 is 3 times 3, that's 9. And x to the power of 2 stays as x squared. We didn't do anything yet with these other parts of our expression, so we can just bring those down. And now, just as we did in the previous example, we will multiply all of this together by multiplying the coefficients. And when you see a negative in front of a variable, remember that that represents the coefficient negative 1. So we have 9 times 3 times negative 1, which is negative 27. And when we add together the exponents on these common bases x by itself is x to the power of 1. So we have x squared, and x to the power of 1. Adding those together gives us x to the power of 5.